Hello everyone, welcome back to the channel. In this video, we're going to talk about the square of a binomial pattern. So for this pattern, we have two examples. Example number one, we have a plus b, or we have two monomials being added together for our binomial, or we have a minus b, so two monomials that are being subtracted for our binomial. So let's just FOIL, so let's expand our binomial, and let's FOIL it out and see if we can come up with our pattern, and then we'll apply the pattern to these three examples. So we have a plus b squared. So that would just be a plus b times a plus b, just like this. So now if we FOIL, we're going to do first, outer, inner, last. So we FOIL, we would say a squared plus, then we would have a times b times a, and then b times b, so b squared. So notice what happens in the middle. We have ab plus ab. Well, that would be 2ab. So we get a squared plus 2ab plus b squared. And that is our pattern that we can apply when we have a binomial squared that has addition. So it's the first term squared plus 2 times the first term times the second term plus the second term squared. Now let's see how this changes when we have subtraction. So this would be a minus b times a minus b. Okay, so we're going to start off the same way. We would still have a squared, but now we would do a times negative b, so that would be negative ab. And then negative b times a, also negative ab. But now we have negative b times negative b, so that would still be positive b squared. And once again, we have these middle terms that are like terms, so they can combine. So we have a squared minus 2ab plus b squared. So those are our two patterns. They are very similar. The only difference there is our middle term is addition when we have a binomial that is a sum. And we have our middle term as subtraction when we have a binomial squared that is a difference. Okay, so now let's apply these two patterns to our examples down here. So in example one, we have 4x plus 3 quantity squared. So we're going to apply our first pattern up here. So if I say a squared, well, a would be 4x and b would be 3, right? So one way to look at this, we could say 4x squared plus 2 times 4x times 3 plus 3 squared. And now we can just simplify. Now be careful, in exponent rule here, we have a power of a product, so we have to give that exponent to the 4 and the x. So 4 squared is 16, so we have 16x squared, plus 2 times 4 is 8, 8 times 3 is 24x, and then 3 squared is 9. So we get 16x plus 16x squared plus 24x plus 9. All right, for number 2, we have x minus 7 quantity squared. So we can take our first term and square it. Now since this is subtraction, we're going to write minus 2. Our first term is a, our second term is 7. Now, be careful there. We know that our pattern says this needs to be minus 2ab, right? So if I go ahead and put my subtraction sign right there, there's no need for me to put a negative 7 in that term, because what would happen? Well, I would multiply and that would become positive 14, and we know it's supposed to be negative, so we don't have to put negative 7, we can just put a positive 7, okay? And then lastly, we have plus 7 squared, okay? And so now we can simplify. So we have x squared minus 14x plus 7 squared would be 49, okay? All right, and for number 3, we also have subtraction. So we're going to take our first term and square it. Now it's going to be minus 2 times 9x times 2 plus 2 squared. So once again, make sure we give that exponent to the 9 and the x. So we get 81x squared minus 2 times 9 would be 18. 18 times 2 would be 36x, and then plus 4. All right, and those would be our solutions there. So one thing to note, all three of these trinomials that we got, those would be considered a perfect square trinomial. So whenever we have the square of a binomial or a binomial squared, it results, once we FOIL it out or apply this square of a binomial pattern, it results in a perfect square trinomial. So that's good for us to remember, all right? And that's the square of a binomial pattern.